All right, I wanted to talk about Aufbau's principle. So I've kind of gone a little out of order in your notes, and that's okay. I just want to try to make it, I want to convey it in the way that makes the most sense. So we talked about electronic configuration earlier, and I may have not said it explicitly, but electrons fill from lowest energy to highest energy. And there's kind of a neat little pattern that they fill up in, and this is Aufbau's principle. So first, let me write down the different principal energy levels, or you can think of this as distances from the nucleus. So like the first shell, right, the second shell, the third shell, the fourth shell, the fifth shell, the sixth shell, etc. I'll go ahead and put the seventh one. And then let's put the subshells next to it. So we've got the 1s, and that's the only thing that's in the first shell. In the second shell, we've got the 2s and the 2p. Okay, in the third shell, we've got the 3s, the 3p, and the 3d. In the fourth shell, we've got the 4s, the 4p, the 4d, and the 4f. Let me write this is 10, sorry, f is 14. Got ahead of myself there. And then in the 5 shell, we've got 5s, we've got 5p6, we've got 5d10, we've got 5f14, and then we're not going to put the G subshell out here because it's like a hypothetical subshell. So I'll just keep going forward this way. 6s, 6p, 6, 6d10, 6f14, and etc. 7s. I know I'm recreating this, but I want you to see it. Instead, it's easier to see it once as it's happening rather than after it's already happened. So 7p6, 7d10, 7f14. All right. So the way that they fill is they fill from lowest energy to highest energy. So the first shell is the lowest energy, and it fills this way. So we've got the first shell is filled first. Okay. The next shell that's filled is the second S subshell, so it's filled next. Okay, before the third S, though, if we look at the periodic table, okay, before we start filling in, let me collapse this. Actually, no, I'll leave it wide. So here we're at 2S. Before we fill in the third S subshell, we fill in the 2P subshell. So the 2P subshell is filled in, then the 3S subshell, right? So if we go back to the periodic table, the 3s subshell is filled, and before we fill the 4s subshell, we fill the 3p subshell, right? So 3p is filled, then 4s. Okay, now we filled the 4s subshell. So back to the periodic table. And I went, okay. So the 4s one is filled. Before we fill the 5s one, we got to go over here, and before we fill the 4p one, we're going to fill the 3d subshell. And now these 3d electrons are closer in than the 4s electrons are, right? But they're lower energy. Or sorry, I just said that. So the 4s fill, right? They're farther out than the 3d ones. The 3d are higher energy but closer in than the 4s. So we filled the 4s. Now inside the 4s, we filled the 3d ones, then the 4p ones, then the 5s ones. Okay? Let's go back to the periodic table again. So we're at 5s here. Before we fill 6s, right? So we're at 5s, 4d. 4d is higher energy than 5s, but it's closer in. Okay, so because 5s fills before 4d, but it's closer in. If we wanted to visualize this, I know it's, well, I don't know. The shapes are really, I don't want to build a misconception in your mind. But 5s is farther out, but 4d is higher energy. So it fills from lowest energy. So S is filled before D because D is higher energy, even though it's closer to the nucleus on average. So 4D is filled, then 5P, then 6S. Okay? So this is called Aufbau's principle. So from lowest energy to highest energy. That's how we fill. Okay, so we're at 6s. Let me go back to here. Okay, 6s, right? The next thing to be filled before the 7s down here is the 4d subshell. Okay, so the 4d orbitals are filled next. Now, those are much closer in than the 6s, but they're higher energy, right? So 6s is lower energy, but much farther out than 4f. Okay, and this has to do with electron-electron repulsion. Okay, so 4f, then 5d, then 6p, then 7s. So I hope you've seen how these things fill based off of this now. Okay. All right. So now that we've established that they fill from lowest energy to highest energy, I want to talk about what makes 2p higher energy than 2s. I want to talk about what makes 3p higher energy than 3s, right? So if we were to look at the subshells, S is the lowest energy subshell, right? Because if we look here, 6s is lower energy, right, than 6p, which is lower energy than 6d. So S is lower energy than P, which is lower energy than D, which is lower energy than F. And I want to talk about why this is the case. And to do that, we're going to have to look at some graphs here. Okay, and they're right here. So the AP exam will ask you to provide some sort of explanation for why S is the lowest energy subshell. Why is P the next lowest energy? Why is D? So that's saying, I'll write it over here just again. So S lower than P, lower than D, lower than F. They'll want you to provide some explanation for this. And the reason has to do with the probability of finding these electrons. So if you'll notice, this graph is kind of hard to interpret. The S electrons, their maximum probability of being found is farther. That was a terrible straight line. I don't know if I have a line. Do I have some sort of line? I don't think I do. That's okay. I'll try my best. We're just going to imagine that Mr. Woodard can draw a straight line, but it's hard with this ink pad. Not very good. But so the 2s electrons are on average, their maximum probability is farther away than the 2p electrons. Okay. However, there is this thing right here. Okay, this little bump on the graph. We do have higher probability of finding an S electron much closer in to the nucleus than a p electron. Okay, so there's like no probability of finding a p electron very close to the nucleus, or it's very low probability, and there's much higher probability of finding an s electron closer to the nucleus. And because we have a much higher probability of finding s very close to the nucleus, okay, it's not that s is on average closer, but because we have this high probability, s is able to get close to the nucleus at times, s has lower energy than p. Okay, because it's able to get closer to the nucleus at points. Okay, we can read through this, but it minimizes the electron-electron repulsion when S gets closer to P. Or sorry, when S gets closer to the nucleus. Okay, and I'll read through this just so I don't do it a disservice. So this small little hump here, that's the distance from the nucleus that a 2s electron occupies, a small but significant amount of time. Okay, we say the 2s electron penetrates to the nucleus more than the 2p orbital. This causes the 2s electron to be attracted to the nucleus more than the 2p, making the 2s lower in energy than the 2p orbital. Okay, then they do some analogy for moms and children being close to them. I'll spare you that. Over here, this is the this is the 3s graph. So you'll notice there is 3 humps for this one, and if we overlay the s with the 3p with the 3d, so here's the 3d. On average, its kind of peak probability is closest. Then D is closest, right? Then S is the furthest on as far as its peak probability. But if we look, S has these two non-significant humps that are extremely close to the nucleus. Okay? P has one hump that's sort of close to the nucleus. Okay? Based off of this, because S is able to get really close to the nucleus, that minimizes the energy requirements. If you were to somehow like average out all of these humps, I do believe that the math is going to be fairly complicated for it. But we would see that S is slightly to the left over here, and P is slightly to the left of D, S is slightly to the left of P. But it's these humps are what accounts for, so these kind of these significant portions of these graphs. So let me try to put this in English. Because the electron spends a significant amount of time extremely close to the nucleus for the S subshell, it minimizes the energy. That's the best I can say it, and that's what I think what they expect you to be able to say. So that's the explanation to this. Why is the S subshell lower energy than the P subshell? Why is the P subshell lower energy than the D subshell? And why is the F subshell higher energy than these three? And remember, that's the explanation for why we've got different energies. But up here, we need to make sure we remember to apply Aufbau Principle. So they fill from lowest energy, so the lowest possible energy state, electrons are filled based off of that. Okay? I'll see you in the next video.